Okay, before we go any further, just want to tie up some vocabulary. So let's say we had f of x and it's a polynomial function and a is a real number. Then the following statements are equivalent. Alright, x equals a is called a solution to the polynomial if it makes f of x equal to 0. So for example, I just drew f of x equals x minus 2. It's simple, but it is a polynomial. Alright, so in this case, a would equal 2 because f of 2 is equal to 0. So that means we would say 2 is a solution to the polynomial. Alright, we can also call x equals 2 a 0 of the function, and x minus 2 would be a factor of the polynomial. And if we were to graph this, alright, we know that it would go through 2 on the x-axis because 2 comma 0 would be an x-intercept of the graph. Okay, now this stuff is really important because it's a concept that I really want you to know, and it's really important for calculus. So if you've been tuning out, definitely just give me these next, the rest of this video of your full attention, but I doubt that happens because you guys have been awesome. Alright, so let's say we have x minus a is a factor of our polynomial, and it's raised to k power. So k is greater than 1. Alright, if k is just equal to 1, so let's say you had something like this for f of x, alright, in both these cases, for x minus 1 and x plus 2, the factor is raised to the first power. The behavior about those zeros is going to be what we call normal. It's going to go through 1, alright, and through negative 2, there's going to be normal behavior. But if k is greater than 1, we have to think, alright, if it's odd, then the graph is going to go through the x-axis at x equals a. Now it's going to snake through it. So something like x minus 3 cubed, alright, or actually let me scratch that. Let's make it x minus 8 cubed so I don't confuse the 8 and the 3. Alright, that behavior around the 8, it wouldn't go straight through, it would kind of flatten out around there. And we're going to look at why that happens. Alright, if k is even, so let's say we had y equals x plus 2 squared. Alright, so here at negative 2, it's going to bounce off that negative 2. Alright, so if the multiplicity is even, it's going to bounce off the x-axis. Alright, let's look at why that happens right now. Okay, so let's look at this example first. So I have two linear equations graphed, y equals x minus 3 and y equals x. And then I have the product of the two, y equals x times x minus 3. Alright, so first a couple things to understand. Alright, we're going to look at how y changes. So the x-axis, we're going to consider any points on the x-axis, y is equal to 0. Any points above the x-axis, y is greater than 0. And any points below the x-axis, y is less than 0. Now instead of writing that out like that each time, if y is greater than 0 for a certain part of the graph, I'm just going to put a plus sign because things greater than 0 are positive. And if y is less than 0 for a part of that graph on a certain x interval, I'm going to put a negative sign. So let's look at the purple line. Alright, I'm going to draw a vertical line right here because that's where the purple line, y equals x, changes from being negative, so it's below 0 when x is less than 0, and y is greater than 0 when y is greater than 0. Alright, so that is like the change. That purple vertical line I drew is where y goes from being negative to positive. Okay. Now if we look at the red graph, and I draw a vertical line right here, okay, on the right, on this interval, okay, or let's do it like this, y is positive, and to the left of that line, it's negative. So I'm going to go negative, negative. And then, just to finish up this chart, I'm going to put a positive here because it's still to the right of the purple line, and like y is still positive on that interval. Okay. Now the black line is the product of those. So if we multiply a negative by a negative, that means on this particular interval, negative times a negative is positive. Alright, that means that the product of those two, which is represented by the black curve, is going to be positive. And then a positive times a negative is negative, and a positive times a positive is positive. Now if we look at these intervals, and I'll highlight them in blue, alright, to the left of the purple line, notice how this black curve is positive above the x-axis. Alright, and then in between the purple and the red line, it's negative. It's below that line because it's a product of a positive and a negative. Alright, and then to the right, positive, positive, y values multiplied together give you positive. It's going to be positive. So by looking at the sign around the zeros of y, you could determine what the graph's going to look like in between those intervals. All right, so now we're going to take that idea and help us understand why bounces occur. And because this video is going kind of long, if you're wondering why I cut these videos up into short pieces, I have to email them to myself because the app doesn't work properly, and it's partially my fault, and we'll get into it. And this is totally not math related, you probably don't care. But if the file's too big, I won't be able to email it to myself. So that's why I cut these videos off in about 5 to 6 minutes. So I'm going to, please watch the next one because I'm going to build on what we just talked about.